Okay, so now we're going to do the 3.4, which is the last piece that you need for test number 3, according to the syllabus that I have here. If there's any change, hopefully I will tell you when we need to know, but that should be the case. In any case, so here's the title. I'm ready for the title. It's got another fancy name. Still involves polynomials, and it's called the rational, rational zero theorem. Okay, so that means rational numbers. So let me show you an example right away. And it's like all really memorization of what to do. I don't think you'll find it complicated what to do, except that you got to remember the steps. All right, so how have we been starting for a long time? We've been starting with polynomials. So here goes another polynomial, minus 2x to the 5. Then no tricks, we'll put it in order here. You don't have to rearrange anything. Plus 3x to the third. As a matter of fact, you don't even need the middle stuff. Give me a chance to explain. And then the last thing that comes is the constant, that famous word called the constant. That's the number without any x, and that's plus 10 at the end. Okay, so now here's what it says on your paper. List all possible rational zeros. All possible rational zeros. Okay, so the list is possible. It doesn't mean that we're not going to definitely get the zeros, but on this list, if they exist, it's going to be on this list. We're not definitely finding zeros. But again, let me repeat. But it's a method by finding all the possible ones. So if we narrow it down to, let's say, 6 or 5, we've narrowed it down to those are the possible rational zeros. If there won't be any that's not on the list. It's not definitely zeros. It is possible zeros. Okay? It's a little strange, but that's what it does. It narrows it down, but you don't know for sure. Okay, so here's what you do. You notice that the constant is 10. You put that on top, and then then you put it like a fraction bar, and then you take underneath over here the -2, meaning the leading coefficient, the highest term. It's got to be in order. I mean, it's good. The highest one's got to be in the beginning, and then you take the leading coefficient. And here's the job we got to do. Here's the method. This is all part of the method. Take that 10 on top, take that -2 on the bottom. And the method is find all their factors. Find all factors of both the top and the bottom. Okay, let me put that over here so you don't get mixed up. Find all factors. So what I'm trying to say over here, that's supposed to be an R. Find all factors. Okay. So that's not necessarily so hard. What are the factors of 10? They can be 1 and 10, right? So that's one of the factors of 10. 1 goes into 10 evenly. So does 2 go into 10 evenly. That's a factor of 10. So does 5 go into 10 evenly. And so does 10 itself, right? So 1 times 10 is 10. 2 times 5 is 10. Though these are all factors of 10. But it's not just that. What about -1 times -10? That's also going to get you to 10. So the minus numbers have to be included. They're also included as the factors of 10. So it's not just 1, but it's plus or minus 1, plus or minus 2, plus or minus 5. So it's not that we have 4 factors of 10. We have 8 factors of 10 here. Okay. Underneath, what about -2? The factors of -2 are, you could have a +1. We have a +1 times a -2, right? but you can also have a minus 1 times a positive 2. So these are all factors of 10. I'm sorry, of 2. Factors of negative 2. How do you get back to negative 2? Plus or minus 1, plus or minus 2. These are all factors of 2. You could have a positive 2 times a negative 1. You could have a positive 1 times a negative 2. They are factors of 2. That's the complete list. Okay, once you have the complete list, let's get rid of this. Once you have the complete list, so now you take the top and match all of them with the 1. The 1 with the 1, 2 to the 1, 5 to the 1, and 10 to the 1. So let me put it on the next line so you can see it clearly. So what we have to write over here is plus or minus 1 over plus or minus 1. Okay, that's 1. There, here's 1. Then plus or minus 2 over plus or minus 1, right? Each one is going to be matched up with that first one on the left on the bottom. Then comes plus or minus 5 over plus or minus 1. Then comes plus or minus 10 over plus or minus 1. Plus or minus 1. Okay, all four have been matched up with that. Now all 4 have to be matched up with this one. So we keep going. We put out 4, but there's going to be 8 of them. So then it becomes plus or minus 1 over plus or minus 2. Plus or minus 2 over plus or minus 2. Plus or minus 5 over plus or minus 2. And I'm at the end of the string, plus or minus 10. And the list is done over plus or minus 2. The list is done, but now we've got to look before we sign off and say these are all the possible rational zeros. We've got to look for redundancy. So 1 over 1, 2 over 1, 5 over 1, 10 over 1, that's fine. 1 over 2, that's a half. 2 over 2, that's the same thing as 1 over 1. 2 goes into 2, 2 goes into 2, so cross it off the list. That's not it. 5 over 2 is fine. It's unique. But what about 10 over 2? 10 over 2 is the same thing as 5 over 1. So you got to cross that off the list. So finally, this and this and this and this and this and this are all the possible, here's the answer, this list are all the possible rational zeros. All the possible rational zeros of the polynomial that was given to us originally, this polynomial right over here. Those are all its possible rational. Somewhere on this list, if there are any zeros at all, it's on this list. Not all these are zeros, but necessarily. But if there's any zeros for this polynomial, then they're on this list, which means we've got to narrow down. Then we could take each of them and test them. We could test, let's say, positive 1 and divide x minus 1 into here and see if it's a 0. We could test each one individually to see if it's one of the zeros. We could find them. Okay, but as far as answering this question is concerned, we did it. We've got the list of all the possible zeros, but don't forget that this is crossed out and this is crossed out. So it's the 1, 2, 3, 4, 5, 6 that are all the possible rational zeros. If you wanted to test it, you would take this. If let's say you wanted to test if positive 1, if you wanted to test if positive 1 was one of the zeros, then what you would do is you would divide this thing by x minus 1. If you got a remainder of 0, then you would say, yes, 1 is a 0. If you don't have a remainder of 0, then you would say 1 is not a 0 of the polynomial. Okay, so that is the story with this video.